Good morning, good afternoon, and good evening. Welcome to the Caterpillar Mining webinar series. My name is Ada Sanchez, and I am the Digital Marketing Specialist for Caterpillar Global Mining. I am based in Tucson, Arizona. Now, I'm very excited to bring you today's topic. It's an introduction to the R2900 XC Diesel Electric Underground LHD. Built on the platform of our most popular underground loaders, the new R2900 XC is the first Cat diesel electric underground LHD. It's a productive, powerful, reliable machine built to meet the underground mining industry's needs for bigger payloads, faster loading, and reduced emissions. Now today, we'll be taking a closer look at the features, the upgrades, and the improvements of this new model. And with me on the call is Gordon Wilkin. He is the HRV Underground Mining Global Product Application Specialist for Caterpillar, and he's based in Brisbane, Australia. But before we get started, a few housekeeping items. The screen in front of you today is interactive, so please feel free to navigate and explore all of the buttons and the sections that surround this presentation. For example, you can find more information about Gordon, as well as myself, in the presenter bio section on the bottom left hand of your screen. And then on the right hand of your screen, you will find important documents and links related to the R2900 XC in the resources section, which is available for download. Now, a word about Caterpillar's #1 value, which is safety. Be safe, be present, champion the power of everyone, and win the right way, and be cyber safe. These are values that we live by, not just at the workplace, but during working hours, but also during the rest of our day as well. Please note that this event is being recorded and will be made available for viewing in the future. Now, I realize that there may be dealers, customers, competitors attending today, or even watching the recording later. So we just want to make sure that we don't share any competitive information that's sensitive. So basically, we won't be discussing things like pricing, discounts, terms, or anything of the like. And if you are an existing customer, please feel free to contact your local dealer for any specific information that you see today. Should you have any questions at any time during this webinar, please use the Q&A section on the bottom right hand of your screen. Gordon will be answering them throughout today's webinar. And if we get too many questions and we don't get to yours, we'll make sure to follow up via email. And with that, I'd like to kick things off with a poll. So I mentioned earlier that this webinar would be interactive. So before I hand things over to Gordon, let's take a peek and see what the audience looks like. So please take a moment to answer the question on your screen. So in what ways do you interact with underground hard rock loaders and trucks, which is HRV? Are you an operator? Are you in mining or quarry operations? Are you in purchasing or maintenance? Possibly safety? Are you here to learn about this product, or are you in training and research, or maybe other? So in what ways do you interact with the underground hard rock loaders and trucks? Take a few seconds here to answer these questions. This will help set the stage for today's presentation. All right, I see those questions being answered. About 12% of attendees have submitted already. We'll give everyone a couple more seconds. It's interactive, so please feel free to answer. In what ways are you interacting with underground hard rock loaders and trucks? And Gordon, we'll give everyone a couple more seconds here. Yep. We want to make sure we get an accurate response. Are you an operator? Are you in mining or quarry operations? Are you in purchasing or maybe maintenance, safety, education, training, or research, or maybe other? So that's something that's listed here today. All right, thank you so much for responding. I think we're ready to move forward and see what our audience had to say. All right. I'm seeing here on my screen the answers. Hopefully everyone is too. Sometimes it takes a couple of seconds to load up. Gordon, are you seeing the answers?
I certainly am. Thank you very much. That's very good. Very broad range of people in there. So that's exciting.
Perfect. So I will turn things over to you, Gordon, to give us an introduction of the R2900.
Fantastic. Thank you very much. Okay, so welcome everybody. Again, good evening, good afternoon, good morning, depending on where you are in the world. It's late evening for me here in Brisbane, Australia. So it's certainly my pleasure to introduce to you, the R2900 XE. For many of those who are online, you may know me. I've been in the underground industry my whole career, and as you can see in my lovely photo there, it's been a pretty long career. So a bit of an agenda there. We've got roughly an hour and a half. There will be a presentation here, and hopefully we get plenty of time to do some questions either as we go through this session or at the end. So we'll just go through the facilities first. So for those who are in the USA region or have the ability to travel that region, we have a mining centre in Tucson. There's a broad range of equipment there, obviously not just underground. There's a whole spectrum of equipment that we have in that region. So if you get the ability to visit that centre, please do so. We do have a small underground presence there. There's some R1700s and an R1600 there, and our R1700 XE is also at that centre. Here in Australia, in Burnie, Tasmania, this is a home of Caterpillar Underground, or hard rock vehicles as we're now called. This is our base for all of our engineering. This is also the base for all our autonomy command systems and the whole lot. So same thing, if you ever get the opportunity to come down to Tasmania, it's certainly a great facility to go through. This is where we used to manufacture all the equipment. It's now been transitioned across to Rayong in Thailand. We do 100% of our manufacturing out of Thailand. So again, if there's a requirement or a desire to see that, we can certainly arrange for people to visit that facility. So the product overview. So this is our current model range. Now, tonight, we're going to focus on the R2900 XE, but just a bit of a refresher of our whole model range. So from the smallest R1300G right up to the largest R3000H. For those who are aware of our previous models, you may notice that the R1700G is not listed there. That's because that model has been phased out. It is replaced by the R1700. There's also an R2900, which was a stage 5 version of the R2900. That's also been discontinued and is replaced by the R2900 XE. But that's our current model range up. So 2900 XE is the focus of today. As with the whole of Caterpillar, we are focused on greenhouse gas emissions, carbon footprint reductions, how to make everything more sustainable, everything we do in mining. And us as Caterpillar as a whole, we have a fingerprint or thumbprint, depending on how you want to discuss that, in the whole process. It's not just getting the rock out of the ground, but it's the processing of that rock. It's the transportation and the refining of that ore all the way through. Obviously today we're focused on underground, and that's the 2900 XE. Electrification. This comes up a lot, and this new machine is part of that electrification journey. It does not have a battery, and I'll get to that shortly. But electrification is a journey that every manufacturer, every customer is certainly on that journey towards electrification as an effort to reduce our carbon footprints. Together with that, there's a very strong requirement to have automation as part of this journey. It helps us to be more productive. Basically, we want to improve the ability of our equipment as far as the energy used. So we now start to talk less about litres per hour or litres per tonne, and we start to more talk about kilowatts or kilojoules, for tonne or for movement. But our whole product range does have a journey towards full electrification. But again, yeah, we're focused on the R2900 XE, and we'll start to go through those details. So this is a short video. All right, so it was just a bit of a taste of the machine. It's a great video, and as per the introduction, this is being recorded, and a lot of this, the video and the material that you're going to see, is available. That particular video is on YouTube. There's also a walk around video done by yours truly, also on YouTube, which will give you a bit more information. So please be free to reach out for those. So, right, we'll start to go into this a little bit more detail. And, the machine has been released on the market now for a little while, and there's a little bit of confusion out there. What do we do? Why did we do it? And there's a little bit of a talk about that this is a hybrid machine. So right at the very start, I just wanted to stop that. This is not a hybrid. A hybrid normally refers to that a machine or a vehicle has a storage capacity for power and has the ability to recharge that storage itself. A lot of vehicles and trucks on the highways at the moment have that ability, and they've normally got a small petrol engine, for example, that'll start and stop to keep that battery recharged. This machine has zero power storage. It is purely a diesel engine, which is rotating a generator, which then powers an electric drive motor. So there's no battery in there. You turn the diesel engine off, you lose all your propulsion. Unlike a battery-powered machine, which obviously has battery power, there's no diesel engine in those machines, and that's what our R1700 XE is. It's 100% battery-powered. This machine's not. So just to repeat that, the diesel engine runs, drives a generator, which drives a propulsion motor. Now, apart from that, it's very, very similar to the previous R2900s. It has a conventional drop box going out to our drive shafts and out to our axles and final drives to get the power to the ground. So in that particular slide, we got the older version up the top, diesel engine, torque converter, high-speed shaft, transmission, and then to your drop box and out. So we've taken the torque converter away, we've taken the transmission away and that high-speed shaft, and replaced that with a generator and an electric motor. Now, for those that are familiar, in the large wheel loader range of Caterpillar, we have a 988 XE or a 980 XE. They use the same sort of propulsion, the same sort of componentry. So very, very similar. In fact, we use a lot of those parts in this particular machine. There's lots of advantages for doing this, and we'll start to go through it. Some of the really big ones is that there's a lot less heat. So a torque converter gets very hot, a transmission gets very hot. There's lots of moving parts, there's lots of oils, it's high cost for maintenance. When you look at the electric drive, these are kept very cool. They have their own individual cooling system, which we'll see in a couple of slides shortly. So they run a lot cooler. There's less moving parts. A generator is effectively 2 bearings, 2 seals, compared to a torque converter, which has many parts. And the same for a transmission. There's lots and lots of gears and clutch packs, etc., in a transmission, where a propulsion motor is effectively a couple of bearings and a couple of seals. A little bit simplified, but that's what it is. This gives us a lot more power. It's just instantaneous power to the ground, or torque to the ground, and it gives us a lot less maintenance requirements. So by going to this sort of technology, we've been able to make a lot of changes to the machine. It wasn't just this that we've changed. We've been able to increase the payload. It was a 17.2 tonne machine. It's now an 18.5. We've changed the whole hydraulic system. The old 2900s were gear pumps. They're now piston pumps. So those pumps they're a lot more efficient. They give us a lot more control over the flow and the pressure to improve our hydraulics. We've also changed all the cylinders. The cylinders have changed their position on the machine to give us more breakout force, but we also have in-cylinder sensing now, which gives us more technical ability as far as what we call snubbing, to take the shock load out of the cylinders. It also allows us to easily automate the machine. We also have auto dig, which we'll talk about more. Because the diesel engine is driving a generator now instead of a torque converter, and there's no slippages in here. There's no clutch packs to slip. There's no delays for the engagement of the clutch packs. We've got a lot more efficiency out of that drivetrain. So by doing that, we're actually able to slow down the engine RPMs. So a conventional loader will run at about 2,000 RPM. This machine only runs at 1,600 RPM. The big advantage of this is there's a less of a heat output by the diesel engine, but we're also burning a lot less fuel. Now, as per the numbers there, 31% more efficient. That's a pretty significant number when you look at the running costs of a machine of this size. The next number down, 52% quicker acceleration. So when you're talking a machine that weighs roughly 60 tonne, being able to accelerate 52% quicker, that's pretty remarkable. That's a great outcome by the engineering team around this machine. And again, that's that ability. There's no lag in the torque converter. There's no slippages through those clutch packs. It's just instant power being able to be delivered to the ground. And the machine therefore accelerates far, far quicker than it's ever been able to do as well. It stops just as quick. So the acceleration is just as quick, but the acceleration is where we get a lot of our productivity from. So in this regard, we've got a bigger payload. We've got a lot higher breakout force. It's a lot more fuel efficient, and we've got a lot quicker acceleration. This all builds up and stacks up to our improvement in our cost per tonne. Our productivity increases, and our cost to operate this machine reduces. So it has a very big impact on everything we've done with this machine. The motor itself is a Caterpillar motor. It's what we call switched reluctance technology. Again, this is used in other Caterpillar equipment. It's a direct drive. There's no slippages. There's no gears. It is a stator, a rotor, some bearings and seals. That's it. That's all that's in there. There's no gears as such. So you've got no gear changes. So therefore, there's none of that shock loading. Every time you change forward to reverse or through the gears, first, second and third or fourth, you'll always get that shock through that whole drivetrain. There's nothing there anymore. It's a motor spinning constantly. It's constantly engaged. There's no gears cutting in and out. So it's just a constant torque. So you don't get that shock load through your drivetrain. And in fact, you can be as fast as you can go forward and make it go as fast as you want to in reverse without taking your foot off the throttle, and there's no shock load. The electric motor absorbs all that, controls all that, and in fact, that's the best way to operate this machine, is to hold the accelerator at full revs all the time. That's where you get the most productivity. So again, very common components we've used elsewhere. There's no power stored on this machine. So therefore, this motor does not regenerate power either. So if you're going down the ramp or you're towing it, there's no regeneration of power because we don't store that. As far as an operator, because I've just said there's no gears in this. So to make it easy from an operator of a standard machine to transition across to an electric drive machine, we've simulated gears or virtual gears. And this machine actually has 5 of those gears. So we've done that electronically. There's physically no gears as such that are changing. It's the way we control the torque and the electricity going to that electric motor that gives us that differential in speeds. One of the biggest advantages of doing this, to make it easy from an operator to transition across, it also means that we can set speed limits for each individual gear. We can set ground speed limits, through our auto retarder system for each individual gear, which was not possible before. Sorry, and I'll just keep an eye on the questions as we come through, and thank you for that. Please keep them coming through. That's great. So there's some additional safety advantages that we've built into this. So as technology improves, we're trying to make sure we incorporate this into every machine model that we do. And as we progress, we're trying to make sure that they're backwards retrofittable. So some of the safety features that have been added to this model is seatbelt monitoring, door and door latch. So in past, we only monitored the door to make sure it was closed. Now we also monitor the latch because there were some occasions where the latch was starting to walk its way out and become detached during operation. So we monitor both now. Neutral creep. That was a really bad one in normal transmission style machines where in neutral, the machine could roll backwards or forwards. That's been taken out. With the next one, the hill start. So you can effectively come to a rolling stop on an incline or a decline. The machine will hold itself there until you touch the accelerator again. So you don't need to use the brake. It'll just sit there. You accelerate away. There's no coasting in neutral. That's gone. Auto retarder is obviously fully adjustable. The operator presence system is there again, just looking for that operator input to make sure everything's okay. And most of these will either apply the park brake, they may even shut the engine down, depending on how the machine has been set up. From an operator comfort perspective, the cab is very similar to the previous model. It's updated the switches, it's updated the displays, but as far as the seating position and the armrests and how you sit, it's pretty similar. But what we've been able to do is now put in some more automatic type features. One of them is the return to dig. You simply press the joystick forward, it'll automatically lower the boom and roll the bucket forward to the desired position that you've programmed in, ready to dig. Instead of manipulating that lever the whole time, you just press the joystick forward and it'll do it for you. We have lights that'll turn on and off automatically with reverse, boom up, and all those sorts of things. High and low beam is automatic. So there's a lot of those things where you as an operator are very busy in the loader. You're constantly working the bucket, you're constantly steering. So we're trying to take away those things that takes your hands off of those controls to be able to turn on switches, et cetera, et cetera. So we're trying to make that as easy as what it can, because we understand that the life of an operator is very busy inside of these machines. Safety, we've hydraulically activated boom support pins. They'll be available for this machine. With a press of a button, it'll insert 2 locking pins into the lift arms for, if you're working underneath them. Excuse me. Traction control is standard. This is great. It helps us reduce the tyre wear, but it also helps us, during our digging cycle to make sure we get the bucket full effectively. And then we have auto dig. Now, auto dig was originally designed for remote control. You can't see what the bucket's doing, and on command, you can't always see what the bucket's doing. So we designed a system that the machine will automatically dig its own bucket. But you can use that in manual operation as well. Yes, there's a lot of good operators out there that'll outperform auto dig. And I take my hat off to them. They're very good operators. They're very skilled. But can they do that every day and be productive every day, where the auto dig system can? It's repeatable. It works really well. In fact, we got some videos and marketing material recently released on that. But it's very good. And if you're a new operator, it'll help teach you how to effectively dig that bucketful. So, a very good, useful addition that we have. Okay, the machine is heavier. It's got more power. It carries more. So we've had to update the final drive. We've got big bearings in there. We've gone to a 4-planet gear instead of the old 3. And upsize, not because we really needed bigger brakes, but because the machine is heavier, goes a lot faster. From a safety perspective, we did have to increase the size of the brakes. So that's all been upgraded. That's all part of this. The axles are also upgraded. We've made it now easier to check for brake wear. We've remote mounted the brake bleeders. So it's not just the operator that we're trying to make it easy for, it's also maintenance. We're trying to make this an easier machine to maintain. The rims are also different, so they don't interchange. So the R2900 of old, the rim was mounted towards the centre. That did make it awkward to get to the bolts and the washers. Sometimes it was a pinch point for fitters to get their hands in there. So now we've made that the rim is, flange mounted, as it's called, or externally mounted. Easier to get to the bolts, safer for everyone involved. Tyre pressure, tyre monitoring is available on this machine. It is a sensor that magnetically attaches to the inside of the rim, and it's monitoring tyre temperatures and pressures on the fly. So if you're starting to get a flat tyre before you get to that stage of doing damage or even a tyre explosion. The tyres had to improve. So this is like the technology that continues to evolve. So is tyre technology. Now, because the machine is a lot faster, carries a lot more, therefore it's heavier, we had to go for a better tyre to be able to withstand that tonne per kilometre per hour that we needed. So we've done that. We've done that in hand with Bridgestone. We do know other manufacturers are starting to produce similar, but this was done hand in hand with Bridgestone. It's called a subterranean version of the tyres that we've had before, and it is a must. You must run this style of tyre. If you try and run the older version, they will fail because they're just not up to that tonne per kilometre hour rating that you need to have. So, they're available as a lug and as a slick, but, we've had to do this mainly because of the increased productivity that comes with this machine. I said earlier about the hydraulic changes. So we've taken the gear pumps off. We've now put on piston pumps. They're a lot more controllable. They're a lot more efficient. A gear pump will take a lot of energy regardless of what the machine is doing, where a piston pump, as most will know, will de-stroke and therefore use less power if you're not using the hydraulic system or the steering system. So big improvement in there. It gives us better control over the flow and the pressures to when we really need them. We've remote mounted the pressure test points and things like that. Again, if you need to diagnose the machine, we're trying to make it easier to get to those sort of components. The other thing we've changed, and this is where we got a lot of our breakout force from, is the lift cylinder. So in the older models, they sat very horizontally. And by lifting that lift cylinder up now so it's more upright, we're now able to get a lot more breakout force. We did also change the tilt cylinder, the tilt link and the tilt lever to help carry this extra payload and also to give us a lot more breakout force. Engine mounts were a problem in the older model. We've upgraded them, we've changed them. They're now a double mount. You can change the mounts with the engine in the chassis. You don't need to pull it out anymore. So again, this is one of these, or one of the many things that we've evolved and developed as we've been able to, as the new technology and processes become available to us to make these sorts of improvements. So we've certainly heard the voice of the customer, all these problems we've had with the previous models. So we're engineering them out to make it easier and easier. Oops, sorry. Cooling systems. So a lot of change into this. Now we need to be upfront. There's actually two separate cooling systems. We still have the main radiator, which is a engine-driven fan on a radiator, which looks after the engine cooling. Very, very similar to the previous model. In fact, the radiator is identical, and you can get that in a Caterpillar version of radiator or the Masabi style of radiator. Air-to-air aftercooler is the same, our fuel cooler is the same. So a lot of that main radiator for the diesel engine is the same. We have taken the axle oil cooler away from that. We now use a cooler that is oil cooled. So in the past it was air cooled, now it's oil cooled. So what we've done, and again this is used on other large wheel loaders, this uses hydraulic oil to cool the axle oil, or vice versa. The axle oil helps to cool the hydraulic oil. We do have another hydraulic cooler as well, it's just not that. But these two run hand in hand. It's a lot more efficient. It means we've got less coolers that are stacked up that was giving us some of our blocking problems on our radiators. So again, it just makes it more efficient. The other cooling system is for all the electrically driven components. So this is your generator and your propulsion motor. Now, the reason the two separate systems, the diesel engine will run at somewhere between 80 to 95 or 90 degrees Celsius, but the electrical components need to run between that 30 to 40 degrees Celsius. So we couldn't use the engine system to cool the electrical system. So hence, that's why we've got two separate systems. The system for the electrical stuff, it has an electrically driven fan, it's an electrically driven pump. So it's all electrically driven and it looks after the electrical components because they run at two different temperatures. Frames have had to change. Again, a lot more stresses in there, a lot more breakout force, a lot more carrying design. We've built in safety stands and jacking points. The front axle mount has also been improved. There was, in the past, some of that joint would fail on us. So again, we're increasing the strength and reliability in those components. Buckets comes up a lot. No, they do not interchange. An R2900 XE bucket is completely different and will not fit the previous model R2900. We've made a lot of changes, we've made a lot of improvements to the buckets, and we can go into that more detail if you like. But we've taken away and been able to design out, where a lot of areas where they used to crack, where the floor used to meet the backing plate, they used to always crack. The corners, the lip corner to the sidewall used to always crack. We've engineered all that out. We've taken all that problem away. But it's also a different mounting arrangement, so they just don't interchange. And we have buckets from 7.4 to 9.8 cubic metre, depending on your ore weight. We need to make sure that we don't go past that 18.5 tonne rated capacity, depending on what GET you're running. Cab, the physical cab is very, very similar, but we've made changes to the interior. We've also made changes to the mounting. Again, this is one of the problems of the old machines. You could not service very easily that top mount. It's now coated with a hard surface It's greasable, serviceable. You can replace the bushes. You can service that top mounting, far easier. We've updated the controls. It's what we call a two-pedal design. So you've got a throttle, you've got one brake pedal. The neutralizer is still there. It's just a switch on the dash now instead of having two pedals. Makes the operator station far more comfortable for the operators. We've got new camera systems. So not only is it the reversing camera, we've now got cameras mounted on the hydraulic tank on the blind side of the machine that look forward and rear as well, to help in your manoeuvring in tight spaces. Dual zippers is what they call the dual bead for your glass. If you have to get out or if we have to get to you, it makes it easier to get in there. So there's a whole heap of improvements that have been made to the operator station. Okay, for those who haven't seen one of these machines, what we hear a lot of is bigger. You made it bigger. It's not. So the purpose of this drawing and the next one that follows is to give you an overlay of both machines, side by side each other, trying to find out, where are they bigger. So the black line is the R2900G. So that's the previous model. The yellow line, if you see that yellow sticking past the black, is the R2900XT. So yes, the bonnet height is a little bit higher, doesn't really affect your vision out of the back. The lift arm is higher. And for most people that see the machine for the very first time, that's that visual impact that makes you think that this machine is actually bigger, because that lift arm sticks up a bit more when you first see it. But it's the same length. It's the same cab height. It's the same wheelbase. And it's the same length and width. So it is exactly the same size. So whenever an R2900 can fit, this machine will most certainly fit. I just saw a question come up about, can the cab be pressurized? Yes, all our cabs are pressurized, and we offer two types of filters. We have a standard dust type filter. We also offer what we call a HEPA filter, which is a lot more finer particle trap. So thank you for that question. So we're just going to pause for a minute. We've just got another poll, and we'll give you a few minutes to do those, and I'll have a flick through some of the questions that have been coming through. All right, might just give it another minute or two, and we'll just about 32% have submitted so far. Okay, we'll move across. Okay, so the question was, how sensitive do you perceive HRV efficiency, production rates, component life to be operator technique and skills? And the majority have said, highly sensitive. So it's a really good question. And I guess I'll be honest, I'm a maintenance fitter. I'm maintenance by background. I used to always blame the operator. It's always the operator. He abused it. He did the wrong thing. And so sometimes, we do blame that operator for some of our failures that's on the machine. So us in CAT, we're trying to engineer some of that out. How do we prevent that? Is it real or is it false that we're blaming the operator for abuse? Or how can we tell if it is or if it isn't? So great question, and thank you for those inputs. Okay, the big one, life cycle costs. Everybody wants to know about this one. So when we designed the machine, we had a very hard, critical look at this model. The R2900 is very, very popular. It's been our machine of choice for a very, very long period of time. but it certainly needed an update. So we had to make sure that we focused in the right areas. Payload is one of it. We always want more productivity. So we've given it, the capacity to lift more tonnage. All right, but we also want more productivity. And sometimes just by putting a big bucket on a machine actually slows it down. So we had to make sure that we increase the performance of the whole machine to be able to use those bigger buckets to dig correctly. Once it's got that bucket full of dirt, can it tram quickly? Can it do it all efficiently? There's no point making it carrying a lot of tons but burning a lot of fuel or blowing the tyres or failing parts. So we had to make sure that we did that correctly as we went through. So we've done that. We've obviously increased productivity by the bigger bucket, but it now digs easier. It now trams faster. It accelerates quicker. By doing all that alone, reduces our cost per tonne. But we wanted to make sure that that wasn't the end of the story. So we've been able to reduce our fuel consumption. And you'll see some real numbers from a customer shortly. Everyone talks about litres per hour, and we need to change this. As we get more into electric drive and particularly battery drive, we need to start to more talk about tonne per litre or tonne per kilowatt. But we've done that. We've been able to make sure that the tonnes per litre have increased. We've made sure our tyres, tyres are expensive. So we've been able to get an increase in tyre life. And most of that was through this ability to get the torque to the ground without that shock loading, but also with the traction control system. Again, there's no point having a machine that shifts a lot of dirt if it's impossible to fix. So we had to make sure that we improve our maintenance. Some of the ways we've done that is, for example, the engine is now a 500-hour oil change. So that saves one oil and filter change on the machine. There's no transmission oil. There's no torque converter oil. There's no filters. So you're saving in that respect. But it's more around that the machine now runs a lot cooler, runs a lot more efficiently, where our maintenance costs are going to start to reduce, and we've had to make the machine simpler to maintain. So hopefully a lot of that downtime has been decreasing. So again, we're just going to pause for a little one here. We looked at operators last time. Now we're going to look at fitters. Whoops, sorry. So we'll just give you a little bit of time to fill in that one. Doesn't look like anyone's game enough to answer this question. There must be all mechanics on the call. All right, so while you're doing that, there's a question that came in about fire suppression systems. Yes, there are provisions there for the bottles. It's a slide-out cabinet. We do offer a fire suppression system ex-factory, which is an Ansell system, but there's certainly capabilities there to install fire suppression systems. There's another one there, is the XE diesel electric on the 29, same to the R2900, 988 XE. Yes, it's nearly identical to 88 XE. So again, thank you for those questions. Please keep them coming through. All right, we'll just check the results of this one. Okay, so mixed bag here a little bit. That's showing the operator results. Should be showing the maintenance results. So we'll have to come back and confirm that one. It might be just a heading, or it could be that the results didn't come through properly. But again, the performance of the machine does also rely on the skill of the maintenance person. So we've got to try and keep that as easy as possible, make it self-intuitive how to do this. So there is on board, there's a lot of diagnostics that you can do to the machine. Some people say, hang on, this is electric drive, so now we need a high voltage electrician to do a lot of the diagnostics testing. That's actually incorrect. The machine itself has the ability to look at the current draw and the voltages and things like that in the electrical system without even touching a screwdriver or spanner. It's all available on the keypad on the dash. So, these are some of the things we've had to make sure that we built into this machine to make it easier and easier to maintain. Okay, test and validation. So when we designed the machine, obviously we tested the machine in our engineering facility down in Burnie in Tasmania, and we had a few design criteria. So yes, we've increased engine power slightly, 10%, but we needed to make sure that it didn't burn the fuel accordingly. Our speed on grade, it's gone up by 8%. Payload, obviously, it's gone up. Acceleration, that's the big one. That's where we get so much productivity, and our breakout force is where we get so many productivity advantages. So if we talk about tonnes per hour, if we're talking about a development style of operation, you should be seeing at least 20% or more improvement. And when you're doing truck loading, it's roughly 12% improvement. Now, we've proven this in the field. The numbers are actually bigger than that. But this is what we've done, performed at our test facility. And fuel burn, again, there's significant numbers. So this is the results from one customer. We had 4 test machines, prototype, field fellows, whatever you like to call them. They went out to 4 different customers here in Australia. And this is the feedback from one of those particular customers. So they have a fleet of R2900G machines, the truck loading, so conventional decline type operation with, stope haulage, crusher feed, the whole lot. So they recorded a 35% increase in productivity in tonnes per hour. Same machine doing the same operation as their R2900G fleet. They obviously saw an increase in lift capacity, which is obvious. We're 18.5 tonne compared to 17.2. They saw a 34% reduction in fuel. So these are customer numbers. These aren't Caterpillar numbers. So this just helps to validate, the performance of these machines in the field. They didn't actually give us a number for tyre life. The machine was returned back to Caterpillar at a certain period. It was a field follow. We had to do a few updates. But one of our customers has seen roughly 3,000 hours out of a set of tyres. So that will vary from customer to customer. So don't say that the machine is going to get 3,000 hour tyre life. Your operation might be more severe or it might be less severe. So your tyre life will vary. And the same with your fuel burn. That'll vary depending on your application. If there's any ventilation people on the call, these numbers are fairly significant. You talk about heat rejection. What does the mine ventilation system have to cope with? Because it's not just the exhaust fumes, it's also the heat that the machine develops. So if you're looking at a 2900G compared to a 2900XE, so short load and carry, that's stockpile type work, that's ore pass, to waste pass or stope to an ore pass, crusher feed, you'll see roughly 84 kilowatt of heat reduction. That's less heat that the R2900XE is putting out. If you're loading a truck, that's 310 kilowatt of difference. That's a pretty major difference in heat output. Again, these numbers will vary depending on your operation. If we're just going to look at fluids, for example, again, a lot of our carbon footprint is based on fuel and fluids or hydrocarbons. The R2900XE, side by side and R2900G, there's a 23% reduction. That's just straight. That's not fuel, that is just oils. That's your savings in oils only. So again, it's a pretty significant saving. So again, we'll have a quick pause, another poll. We'll just quickly let you answer some of these. All right, so while you're answering those, there's a couple of questions here that I'll quickly answer. Is there any parameters to monitor the performance and health of the generator using CAT-ET? There certainly is. That's certainly all available through CAT-ET, but you can also do a lot of it on the machine, so you don't need CAT-ET for all of that troubleshooting, but certainly CAT-ET will do that. Why is the electric-based powertrain more efficient than a torque converter? So effectively, a torque converter is an impeller and a stator and rotating devices that are driven by oil. So there's a lot of oil in there being thrown from a part to a part to make it to turn. That creates a lot of heat, a lot of slippage, where an electric motor is direct. There's no slippage, there's no heat, so you don't get that torque converter slippage, as it's called, and you certainly don't get that slippage during your transmission clutch packs engagement and disengagement. So that's where a lot of efficiency is done. There's just no slippage and no heat in an electric drive. All right, we'll just go through this poll question quickly. So this again was how do you perceive the efficiency of production based on maintenance and maintenance planning and skills? Fairly high rating there is highly sensitive and agree. Yeah, it's all important. The operator is important, the mine plan is important, and certainly the maintenance is important. Getting any of those wrong, and it'll certainly start to affect the ability of the machine. Sorry. Okay, innovation and technology. I just had one here. What's the oldest machine in operation? So the oldest machine in operation is currently just over 3,000 hours old. It's one of those first prototype machines. It's our what we call a long-term test machine. It's actually stopped at the moment. We are taking all the components out of that, the drivetrain, axles. We're tearing them down to make sure that they're engineered correctly. No premature failures are starting to happen. So it's around that 3,000 hours old. We have sold a lot of machines, but they haven't got to that life at this point in time. Okay, technology. Again, this is all as the machines evolve, the technology evolves. We want to make sure that we're capturing and have available to the customers the latest tool that is certainly available, the latest technology that's available. So through our technology group, we can offer a whole range of technology, for all our new models. So that can be from the old line of sight type remote controls through to tele-remote, and then into our automation style of machines. So one of those options is guide assist, where the machine, you'll tell it to go forward and reverse, but the machine will effectively try and self-steer it so it won't hit the wall. You've got co-pilot, which is another step up from that. And then we go into full autopilot. So this is a truly hands-off operation. You assign the machine to go from point A to point B and do X number of buckets or X number of tons, and off it goes. It'll do the whole cycle. It'll tram backwards and forwards. It'll automatically fill the bucket. It'll automatically dump the bucket. It'll do the whole cycle autonomously. And we've got machines running at the moment where we've got basically 3 machines and only 1 operator. And the operator is only there to oversee the effectiveness of the machine, to make sure everything's running smoothly. So there's a lot of ability there. And this is fully available on the R2900XE. Complete autonomy all the way through. We now have higher speed tramming than what we've had before. And this is a big part of that auto dig and auto dump, where it'll do the whole cycle autonomously. Okay, so again, we'll just pause for a moment. Again, how do you perceive the efficiency around the mine plan and design? And I'll have a quick look through some questions while we're doing that. And thank you very much to everyone that's submitting questions and, submitting to these polls. It is good to understand the audience, and obviously we want to try and cover as many questions as possible during our time together today. So please keep them coming through. It's very much appreciated. All right, we'll just have a look how we're going for this one. So mine design, wow, that's a big number. 83% is the feedback that we're getting, that mine design is very important to HRV efficiency in production. I agree. It's very, very important. There's no point having the decline or the ramp too steep, or the drives are too narrow or too wide. If you're truck loading, you've got to make sure you have adequate height to load those trucks. Your turning points, there's no point having a 90-degree corner if the machine's not capable of going around that corner. So sometimes you round those out. Maintenance of those haul roads, water, getting the water off the roads, all those sort of things, is certainly very important about making the machine efficient. If the machine's not efficient, yes, you're going to start to have higher breakdowns through component wear or impact damage, or other things that'll make the machine that's not quite so efficient. So there's really good questions just come through, so I'm just going to pause for the moment. It's around electrical components with water getting in them. Let's be honest, our machines underground, quite often it's wet. They're being pressure cleaned a lot. It's a very hot, humid environment in the underground mine. So having, high voltages, we're talking 750 odd voltages on this machine. So of course there's going to be concern around voltages. So the design of the machine is listed to what we say is IP69K. So most of the wiring is designed to that level of sealing, which is a very, very high rating. Some of the components are rated at IP67 and IP65. So very high level of electrical sealing around those components, be it the cables, be it the controls or the motors themselves. So very good sealing around those. We understand that machines are going to be pressure cleaned, so of course we've taken that into account to make sure that all these things are well and truly sealed up. They're not designed to be submarines, they're not designed to be submersible. So there is care to be taken. However, they are very, very robust. So it's a great question. And the other part of that question was around the liquid around the electrical components. Again, a lot of these components are designed to be liquid cooled. So the drive motor and the generator have coolant inside of those components to keep them cooled. So all the sealing ability is in there. So great question. Thank you very much. Getting towards the end of the slide deck. So there are some GET offerings that we have with our buckets. You can have the modular weld-on type system, which some customers do use. Yes, it requires welding and Boilermakers to change that, but it is a very thin package. It can penetrate the rock pile very efficiently, and it's very light. So some customers do love those. The bolt-on half arrow is also very popular. Like it says, it's a bolt-on type system, and again very popular around the world. In the 2900 XE, it's 65 mil thick, and it has a great life. And we also have half wear options and things like that for your corners. And then we go into the Duralock system. Some people might be negative towards the Duralock because we had some retention issues. We've resolved that. We've got past those issues. We're continually to develop that Duralock type system. But I'll be honest and upfront. We've had some retention issues, but we've got that resolved now. It's a very well accepted product around the globe. So it's very good. Like we said, it's easy to replace. It comes in 3 different options. Be it the standard or the high abrasion or the high penetration type systems. So very popular, around the world. Right, we've got to the end of that. So we're now open to questions as we go. So please let them come in through the chat. I'm just going to go through a couple more here that have already come in. There's a question here, what's the main differences between the 988 XE and the R2900 XE? So to be honest, there's not a lot. The generator is basically identical. The inverter box that we use has some different sealing in there, has a couple of different controllers in there for the underground environment. The drive motor is slightly different on the drop box end. There's a different sealing arrangement there and a different mounting arrangement, but the drive motor itself is effectively the same. So lots of common parts in there. Obviously, our controlling software is a lot different to a large wheel loader. So, the software and that technology is different, but the physical hardware is very much the same. Another one here, change to hydraulic system capacity, total system. Okay, the physical numbers for the gallons, I'm sorry, I don't have those numbers in front of me. We certainly have designed the machine to run for a full 12-hour shift on fuel, and the hydraulic tank is larger than the previous model. But those, sorry, I didn't see who sent that question. If you reach out to the dealer, they'll certainly provide that with our specifications and sheets that are certainly available. I'll also reply to you with those numbers as well. So we'll get those through to you. All right. Okay, where can we see one working? Okay, there's at the moment, the only machines that are physically operating are in Australia. There's there's 3 physically operating at the moment. There's an influx of machines following, and some of our field follow machines are returning back to work as well. So towards the end of the year, we'll see quite a few machines that are in operation around Australia. It'll depend on where that customer is for the ability to be able to see that machine and how old that machine is. This question actually came out of Europe. We have sold some machines into Europe. They'll be heading across to that region later this year. So I'm not quite sure where you are, but reach out to your local dealership there, and they might be able to point you in the right direction for a machine coming into Europe that you might be able to have a look at. Okay. Going forward, do we get both R2900 XEs? Okay. So the R2900G will remain in production for quite a long time yet. So, easy 2, 3, maybe even 4 years yet. So you still get the option of buying the current R2900G, or you can buy the R2900 XE. Now, I guess one thing I didn't say, the R2900 XE has 2 engine options. One is the stage 5, which covers the USA and Europe as far as required emissions and the stage 5 requirements. For other countries aren't quite as demanding or regulated, we do have a tier 2 engine. We are, however, seeing customers around the globe, most of them are buying stage 5 because that's the way the world is progressing, to be cleaner with those engines. But tier 2 is available in the XE. But yes, the R2900G will be around for several years yet. Okay, mechanical drives have an advantage of auto-retarding using mechanical transmission. Okay, so for auto-retarding, that is done through the electric motor. It's not done through the wheel ends or the brake packs. So yeah, you could retard through a traditional transmission, but with the electric motor, all the retardation is done through that electric motor. The diesel engine actually has an exhaust brake as well, so you very rarely touch the brake pedals. Okay, how's that taken care of in electric drives? Yeah, okay. So in this machine, you very rarely touch the brake pedal. You know, you can slow down, you can retard through that electric motor system. Is there any mechanism to stop down speed of the motors? This machine's going down a haul road. Yeah, there is. So you can still use, you know, your auto retarder system if it needs to bring on the brake pack. We'll still do so. But again, you know, there's a lot of capability in an electric drive to be able to slow you down, to be able to retard the machine. We've got the exhaust brake on the diesel engine to help retard you, and if absolutely necessary, the retarder system or the operator can bring on the brake packs to slow you down. It's very, very efficient. Our Burnie test facility has a 1 in 5 concreted ramp, and we can go down that slope in second gear with a full bucket and not touch the brake pedal. The machine will hold its gear as it goes down there. So the retarding system is very, very efficient. What is recommended SMU to perform component rebuild? Okay, great question. So when is this machine due for a rebuild? Or component change out? So what we've publicised is that the components on this machine should last roughly 18% longer than an R2900. That's a very vague answer. And this will vary from mine site to mine site, to operator, maintenance to maintenance. So we publicise at the moment that the component rebuild on this machine in writing is approximately 13 to 14,000 hours. However, with the right operation, you may get more life than that. So don't focus on the numbers I've just read out. What we need to focus on is how is your site currently performing, and then we can then start to plan with you as a customer where you would see those component lives ending up. They will certainly last longer than an R2900 or an R2900G. They'll certainly last a lot longer. Retarder uses electric resistors. No, it doesn't. There's no resistors in there. What we do is actually, you know, we can put power into the opposite side of the rotor of the electric drive to slow it down. You know, like reverse magnetism as such. You know, it's certainly not resistors. DGMS approval, which is mandatory in India. We are approved for India. I'll just need to check the DGMS. But I certainly know that we are compliant to ship machines into India today. So it might be just particular what your operation is there. So I'll double check that one and come back to you. So again, yeah, thank you very much for all the questions. That's great. Very good questions that are coming through. Everybody wants some stickers and hats, yeah? Okay, there's another question here. So why did we do diesel electric and not to battery? So it's a great question. And when we look at the world today as it sits in underground mining, yes, there's a lot of media around fully battery powered machines. And don't get me wrong, that's great. That's, you know, the way the future needs to go. We need to get rid of diesel engines completely. The limitation of today, though, is recharging of those batteries, the runtime of those batteries, where you need to put that major, and it is major, electrical infrastructure into your mine site. How do you manage the power required to recharge batteries, and where can those battery machines operate? So with a diesel electric machine, it doesn't have the restrictions on where it can go. It can go anywhere in the mine you like. You start the diesel engine and off you go. Whereas a battery powered machine, you could be limited on where is your closest charger? What is my battery runtime? Yeah, can I swap a battery? Is there a spare battery? Do I need to fast charge? So that's the advantage of the diesel electric. It's not restricted due to your electrical infrastructure of your mine. It can go anywhere. You can drive it, out of the mine to the surface if it's a tunnel type operation. You can do whatever you like with that machine. So wherever your conventional diesel machine goes today, the diesel electric machine can go. Yes, it's not zero emissions, but it's certainly much reduced in the emissions that it outputs. So that's why we've gone down this path. Red, there are 2 emergency exits. Can you explain these exits? Yeah, certainly. So obviously we've got, the main exit is the cab door. The secondary exit is over what used to be called the transmission bonnet. Basically, when you're sitting in the operator cab, you push that window out that's in front of you, and then you can climb out of the machine, out over the bonnet towards the hydraulic tank side of the machine. You can also easily push out the door window. So if you can't open the door for some reason, that window can also pop out. So they're your 2 main emergency exits, out over what we call the transmission bonnet, or out through the front door through that glass if you can't open the door. And we've now made it easier by having that dual zipper style of seal around the glass. So yeah, hopefully I'm answering all these questions well enough. If not, please let myself know, or one of the team, and we can certainly get to you. Is this machine commercially available today? Yes, it certainly is commercially available to most regions around the world. There are a couple of countries that we're currently not compliant, but we are working towards that. And if you're a customer, please reach out to your local dealer, and they'll certainly be able to assist you in that process. Have we done any production studies? Yes, we certainly have. We've done production studies against an R2900G. We've done a production study against the bigger R3000H, and we've done production studies against the Sandvik LH517. And we hope to very soon do a bit of a study. It won't be a full study. We'll do a study against an LH621 Sandvik machine. Some of those results are available today through your dealer network. So if you're interested in those, we can certainly try and share some of that information on how it stacks up with our own Caterpillar machines, and also, in particular, the Sandvik models. All right, I think we've covered most of the questions. Okay, thank you for that feedback in answering my questions. Thank you. I love that. Yeah, I'd love a hat. I'd probably love a hat too. So thank you for that feedback. Very good. Okay, so we're getting close to our final time. I'll just do one last check here for any more questions. Okay, auto dig. There's a question there about auto dig. I think I covered that fairly well, but I'll just go through that again because it is a fairly significant achievement with our machine models. So auto dig is exactly that. The machine will dig its own bucketful. So you as the operator, either in the machine or on the whatever form of automation or remote control you have, you still control forward and reverse. You still control steering left and right. You still control the throttle. You still control the brakes. The machine controls the boom or the bucket. So it'll do the lift and the tilt, and it'll work that bucket to get it to its fullest capability that it can. Now, it's constantly sensing, wheel spin, engine power, articulation angles, all that sort of things to make sure it's operating to the best that it's capable of doing. It's also sensing the weight in the bucket. So it'll then, through a whole system of, computerized functionality, will decide whether it needs to lift or tilt, or whether the bucket now has its rated payload in it, and it'll just rack that bucket back ready for you to put it in reverse, and off you go. So even once it's got the bucket full of dirt automatically, it'll even give it a final little flick to get rid of any loose rocks. So then you're ready to go. So it completely does that. If at any time there might be a big rock there or it can't fill the bucket for whatever reason, it will abort. It'll wait for you to take control, either reposition the machine or maybe dig that bucket full manually. During the dig cycle, if you touch that brake pedal or touch that bucket joystick, it will abort. And you can take the machine over at any time that you like. So again, the auto dig is very repeatable. It's fantastic on any sort of remote control or autonomy, command type system. It's also a great learning tool for anyone that's new to the underground mining business. Okay, couple of last questions here before we run out of time. After treatment options like stage 5. Okay, so the stage 5 engine runs what we call is a SEMPAC. It's an exhaust management system. It's part of the stage 5 exhaust purification that is required on these machines as part of that stage 5 design. So there's a lot in there. It does require exhaust fluid or DEF or urea, whatever you call it in your region. So it does require that exhaust fluid to be able to get to stage 5, and it goes through that exhaust management system. For tier 2, you can either have a standard catalytic converter, or with tier 2, you can also put on a particulate matter filter. So that'll help you, clean up the tier 2 emissions. Hopefully I've done that one. Where can we find recording this webinar? I'll let Ara answer that one shortly. Is there any truck like 8045 which you are for loading purposes? Yes, we do have an 8045. I'm not quite understanding that question. So is there any truck like 8045 with which the R2900 works for loading purposes? So yeah, an R2900 can load an 8045. It can also load the bigger truck, which is the 8063. So yeah, it certainly can do that. This is roughly a 3 or 4 pass load for an 8063. So we certainly have trucks that we can match with our loaders. Okay, I'll stop there. We're nearly out of time. I'll hand back to Ara for the closing comments.
Wonderful. Well, thank you so much, Gordon. We really appreciate your expertise here. So as far as the recording goes, it takes about 24 to 48 hours, but this video will be available on demand for everyone in attendance. So please feel free to share it once you receive that link. We'll also be posting it on cat.com and maybe even on social media later. But thank you so much to everyone in attendance. We hope you had a great time joining us today, and make sure to join us in our future Caterpillar mining webinars. Thank you and have a great day.
Thank you.